I think we can start this call. Like I said in the chat, we have a surprise awaiting for you. So please be active during this call because we may ask something related to that in quiz. Okay. Okay. Let's jump to the next slide. Cool. We have a two great speaker with us today. Uh, First one, we have Krishna. Krishna has a lot of experience in data scientist. He's a data scientist 3 at Wikimedia Foundation, and he's a founder of Indic Wikimedia Developer Group. He has been into communities for a long time and has really good knowledge about Wikimedia Foundation and data science, and his contribution to community is very much impactful. You will learn a lot of things from him today. And second speaker, we have Agamya. Agamya is a full stack developer. He has strong passion in web development, and he expertise in JavaScript, working with technologies like Node.js, React, Express, and SQL. He's also a part of Google Developer Group, Prayagraj, and Wiki Tech Club. Cool. Krishna, is it like, do you have a permission for mic?
Yes.
Yeah, cool. Let's start this call. Over to you.
Yeah, I just turned on the camera, but I have to turn off because my camera is not that great today. But yeah, hi everyone. I'm Krishna KC. I'm a data scientist on the product analytics team at the Wikimedia Foundation. We work with different product teams to generate insight of how users are using Wikipedia. And yeah, today I'm going to talk about one of my favorite topics, SQL, which I use a lot. Like 50% of my work is just writing SQL queries. So yeah, let's dive into the slides. And so the way we will be doing it is I will show you some of the concepts, like we will talk about some of the concepts of SQL. And then after we learn a few concepts, I will show a live demo of the query on Wikimedia data, because we are in a Wiki session and Wikimedia data is open. So we will do a live query to see how the data looks like in Wikimedia. And so before I start, I know like most of you, like all of you engineering students, can you just on chat or maybe on chat, just if you know SQL, can you just like show, mention something like SQL or like your experience, so that I can quickly know, or like you can also do an emoji, you know, like how people. Yeah, I see a lot of people. Ankit, I think I can sharing my screen. I think you can stop sharing. Okay, so SQL and databases. So at any point, if you have any questions, feel free to raise hand or like ask on chat this point as fast as possible. So the concept of database in SQL is it's a bit fascinating with the whole big data boom that happened in the last few years. There has been this misconception that you need to learn SQL only if you want to become a data scientist or a data analyst, or like a data, like if you want to become a data related role, but not otherwise. That is a misconception. You will need to learn databases and SQL irrespective if you go. I mean, obviously, the data science, like if you want to go into a data science role, you'll have to learn more concepts. But you'll have to, even if you're not doing it, maybe if you want to become a web developer, or like mobile app developer, or like any kind of, like if you want to develop desktop applications, you will need to learn databases and SQL, because that's how applications store data, and that's how your applications access data. So SQL is not just for data analysis. That's one I wanted to give that set that expectation that this is not just for data science. So at the database, like what is a database? It's a storage of data. Data is anything. Like I mean, if I'm, let's say there is a Google, like you're in a Google Meet and like there's a lot of data here, like who is participating, what are the preferences, what is their image, like their mic preferences, their video preferences, like message preferences. So all of this on the back end, Google stores it in a database. And whenever the application is loaded, it loads the set like these things dynamically, and then the front end processes them into like whatever according to the data. So the database at the fundamental level is like a bunch of tables. Like there's a table 1 and table 2. So just a quick example of how a database layout looks like. So it is, for example, this is a recipe database, and it is a bunch of tables which are connected. We will see more about how the connections happen. So there's a recipe, and then there's a recipe category, some users of recipes, and then what are the ingredients? They have their own table, and the categories, and like the different steps. So everything is stored in a database, like in different tables according to the need. Why do we need to break down into these different tables? Why can't it be a single? Like why can't it, there's always this question like why can't it be a single table like all together with all the information? It's for multiple reasons. We'll not go deep into the database design here, but it's to break down into like smaller parts so that it's easier to fetch for the like the computer, and also for us to, and the if you want to access it, you can only access the information that you need. For example, I just need the ingredients, then I don't need to access the whole thing and overload the system. It is fine for like, I mean, if you have a few hundred rows, but if you have like, let's say, I don't know, like Wikipedia has millions of rows of data, and just selecting everything is, it's not efficient. So the data is stored in database, and then SQL is a language that's the interface, which it's like a interface for how you can connect with the database. Like, so how to get the information, how to put in information, like how to transform and get what you want. So that's the quick intro to databases. And yeah, so as I was explaining, it is structured data. It has tables, rows, and columns. You can think of it as a spreadsheet, like a big spreadsheet, like which is like connected, interconnected. So like you have column names like on the top, and then like there is information in like in the rows, and then you have like if you take a Google spreadsheet, there are different tabs. So those are the different tables you can think of in a database. But yeah, of course, spreadsheets have limitations. You can't do everything. So databases are like advanced spreadsheets in a way, and SQL, like, and it has like different structured information and like a lot of metadata related to the data. They power everything. They power the applications, and like it's a real world tool. So yeah, so as I was saying, so SQL is the interface, like it's the language interface to connect to a database. Like, how do you connect to an API? For example, you take Python or like PHP or Node.js or whatever. Like, you have a language, like a programming language interface to connect to the connect to an API. Similarly, to if you want to get something from a database, the only way is SQL. There are other ways like Spark and everything, like which are a different concept, but the core level, everything is a structured query language. So structured query language, like what is structured query language? Is the way you ask information from a computer. It is just structured into like different keywords. and so that the computer knows what you're asking. Once you learn SQL to a decent extent, it'll almost feel like it is just English. We're asking in English, like, but in a very structured manner to give you information in a certain way. So yeah, so that's the introduction to SQL, and then we'll go into some of the examples, like the different commands we have. So the basic layer of like what we call as the commands in any programming language is not just SQL, but what we call as the CRUD operations. So create, read, update, and delete. So in SQL, create is when you create a new table, like so you initiate a database, and then you create a new table. You use insert. So insert. So for example, this one. Yeah, sorry about that. So for example, insert. So the statement is insert into customer table. This is the table name. Like I want to insert customer table. Like which columns to insert, like the name and email, and what are the values. So this order. So the order you give here, and that should be the order here as well. This is important to remember because if it is of the same data type, for example, like in both cases, in name and email are both strings. If you, like, I mean, here it is 2 columns. Here it is 2 columns, but usually it is like sometimes there'll be like 20 columns. You should, of course, like there are methods to ensure the data consistency. But if you, since both these are strings, what will happen is if you interchange, for example, Alice to like email with a name, it will still insert without an error. So that will lead to data quality issue. So it's important to like see your column order and like your value insertion order. So that's how you like insert. That's the create operation. And then we have the read operation, which is okay. Now you have the database. Like, about how do you read from it? So the read operation is select. It's very simple. We'll talk more, but like at the basic level, what I call as like there are 3 fundamentals like for the read operation in SQL, which is what do you want to select, from where do you want to select, and what are the conditions. It is not in this example like so the where, like I want edits from 2024. I want users more than 100 edits. So it is divided into, I mean, of course, there is a lot we will learn later, but at the basic level, you need to understand what do you want to select, from where do you want to select, like which table, so the customer's table. So here, what is the star is like a wild card, so it will select everything, customer's table, and get you all the like. So it's basically if you want to get all the data from the database, so that's like it is a simple command. And then like if you want to apply any conditions, that goes in there. So you'll see where here as well. And then we have update. So for example, like even in an application, you might change your email or you might change your phone number. So then the application will have to go and update the database. So it's very similar. So you have your customer's database, and then you have the set, which is saying that set the column name email for this, like this is the email, but who to set it to, like not just everybody, right? So when the name is like for this user, because they might have changed their email, so they want to change. So once, like imagine an example, you go to an interface and then you change your email. So this is what happens in the backend. The application sends this SQL transaction, what we call as a transaction, to the database, and then it gets updated. So that is the basic like the CRUD operations. Of course, there's delete as well. Delete is similar, like delete. You can do, there are 2 ways, like delete star from customers. For example, if you do this, like instead of select, it will just delete everything from the database. Oh, sorry, from the table. But if maybe, let's say user deleted their account, they want to delete their account, then what you do is you do something similar to this. Delete from customers where the name equal to this one. So if there's a username with this name, so just delete that. So the account is deleted from the database. And that way the account is deleted from the application. So that is the basic CRUD operation. And so this is how a sample table looks like in the database. Okay. So you have, for example, this is the products table. You have product name, category, price, and quantity. So maybe this is like an inventory, warehouse inventory, like what products they have and like what the price and how much quantity they have. So that is like a basic structure, just what you see usually on like a spreadsheet or something. Yeah, so this is just a more breakdown of each of the CRUD operations. So create is insert into product. So see if you see this, the order of the columns is matching the order of the values being inserted. That is very important. Some SQL, so this is like a typical your database setup like requires this, but like some databases like the configuration, if it is set, like if you try to insert, let's say furniture into the third position, which is a string, but price is an integer, it would have been set as an integer. It will throw an error that like data like type mismatch, but sometimes it won't. If the configuration allows it, it won't. So you'll have to be careful yourself while doing that insert operation. So if you see, first we had 3 laptop, phone, chair, and now once the insert is done, and they have 4, like the 4th one, table, furniture, category furniture, and price and quantity, what we inserted here. And then, yeah, the next operation is select. Here the example is, so I was saying this, like, what do you want to select, from where do you want to select, and what are the conditions? So this question is, I want to select all products from electronics category. So this is how you do it. I want to select all products from electronics category. So select star, which is basically all, from table, products table, and then category is equal to electronics. That's the basic select, and which gives me this result. So electronics. Remember, if the other 2 products are like their furniture, so that are not, those are not being selected. But what if I want to just need, like, so in this previous query, we just have like select star, which is basically giving everything. But what if I want to select only 2 columns? I don't need everything. Like, maybe I don't need the category because I already know the category. These are all electronics. So in that way, you just specify the column names that you want in whatever order. So here the order doesn't matter. You can select in whatever order you like. Maybe you want to put price first and then product name and then quantity. That is fine. You don't need to select in the same order that the database has the data. So yeah, so you see now there is no category here. And then update. So the chair's price has increased now. So how do you update? Is like update products, set the price, and then where for the product chair. So if you see, there is a pattern here. Like it is almost similar to how you speak English. Let's say you're giving an instruction to an assistant. Imagine you're the warehouse manager and you're giving instruction to the assistant that change the chair price to 120 rupees. So that is exactly, of course, like there are standards. It's not exactly English, but it is very similar to that. If you see the like the flow is like that. Update the products. Let's say like you have a log, change the price, like which is a set, and for what is like chair. So now the chair's price is set to 120. And then maybe there are no more tables, or maybe you stop selling tables at all. So you don't need that. So just go delete from the table, and so delete from products, and then what you want to delete is like the table product. And that table is stopped. So this is okay. So the four basic CRUD operations, like create, read, update, and delete. And then we have, okay. So then this is like another sample data, like this sample data, which we'll be looking at, like employee ID, first name, last name, department, when they were hired, and what is their salary. A typical company database. So basic data retrieval and filtering. So now we'll be talking more into the data like retrieving part, because that's the core of what you do in like SQL more than anything. Okay, so yeah, so basically you have seen in a previous example, you select whatever the columns you want from the employees table. This gives you this result. But I want to now like say I want to get employees from engineering department. So again, think of it as like like one of the best ways to practice SQL writing in big, like when you're beginning, is to think of it as like you're asking someone to give this data to you, and how would you structure it? So the question I have here is, get me a list of employees from the engineering department with their names. So you have the data somewhere, like of course you want to know the table name. So what you would do is select get me, what do you want? I want the names of people and the department. Of course, from where is the employees? And now you have a filter, right? Like I want from engineering department only. So you apply the where condition, department equal to engineering, and then end the query. And that will give you the results. So that's how you like one of the best ways to practice again like SQL is just think of it as like you're giving this instruction to think of it as like you're giving this instruction to an assistant. And how would you frame it in like English? And it's the same thing you will apply here. Now the next question I have is, I want to order them by salary. I want the top paid employees in the company. So the keyword here is order by. Order by is the keyword that that is used to order by salary, and you have to specify the order. So SQL by default, the order is ascending order. So it'll by default sort by the lowest first to the highest. But if you want to get ascending, you don't need to specify any keyword. Like you can just do order by salary and close the query. But if you need to do it like reverse, like descending order, then you need to specify this other keyword. Simple. So yeah, you can see you have the employees from higher salary to lower salary. Okay, now limit. So limit is saying give me just 3 results. Like there might be a lot of people, but then give me just 3 results. Usually the reason why we would do limit in like practical applications is for example, you want to see what the data looks like. So first time I'll show you when we do a Wikimedia query, like of course, like there is technical documentation for each of the tables, but I mean, like I don't know how the data looks like. Like the documentation has text, like, but what the data actually looks like. So in that case, instead of just selecting everything, you a sample. So just give me 3 or like 5 to see and get a sense of what the data looks like. Otherwise, it's very hard to just work with like just by reading documentation, you can't write a query. So that's one of the reasons why I use limit, and also when you're building a complex query, multiple joins, like a big 100-line SQL query, we limit at an initial level, like so that it does, we see if it is working, and then we run the whole thing. Because every time, let's say you're testing, and like while testing, every time you run like across the million rows of data, you'll just, of course, like it might overload the system, but also you'll end up wasting time. Because limit, when you apply a limit, like the computer has to work with just those 5 rows instead of a million rows, so it will be much faster. Yeah, so it just gave me the first 3 results. So now, whatever we have learned, let's combine everything. I want to select all the employees from engineering who have more than 60,000 salary by hire date. So what does this give me is, this is like a hack to give me the first employee of by hire date in the engineering department, and like who has a certain salary. So what happens is, the query will first, you will select all your employee names, like whatever the columns you want from the department. So from the employees department, salaries filter. And when you order by and then limit, what will happen is it will first order the results. So by hire date, like so it will first keep the first hired person on the top. And then when you apply limit, it gives you the first result, which is basically the first person to be hired. You can also do this by salary. Maybe you want the top paid salary employee. So how would you know that? Is like you can order by the descending, the previous you have seen, and then when you limit 1, because the results are already sorted like from top to bottom, so you'll get the top grade employee. So yeah, so we have the first hired person in the engineering part. So that's the like the first level of like the basic SQL commands. Now, before we go into grouping, so what do you want to select? From where do you want to select? If you have any conditions, if you have any, what do you say? Like, do you want to order the results, and then you want to apply any limit? So that's the first level of SQL commands. So I was telling you we can do a quick demo. So Wikimedia data is public. One of the reasons is like Wikimedia is completely public, and the database layout. Of course, we won't go into the Wikimedia data right now because it's out of the scope. But here are the links that you can see. Program Ankit will share with you. So this is the Wikimedia database, and we have a tool which is available publicly called Query, which allows you to query Wikimedia data. What is Wikimedia data is like, we have Wikipedia. Of course, you know that Wikipedia, different projects are there. We have seen in the last session. People make edits, people view pages, people add images. So all of that is data. So we have the data stored, and like you can run analysis. This is one of the best tools out there to practice. Facebook or some like Google, they just give you dummy data practice, but you can practice with live actual data, which is if someone make an edit on Wikipedia right now, you can query that here. So it's a real world. You can get experience with real world like data and live data, not just real world, but also like actually live production data. So how do? You go to the tool. You have this interface. You can log in with your Wikimedia accounts. Like nothing. Only to create a new one. It is a single sign-on. And then you click on new query. You can also view recent queries, like they're all public. If you want to see like a lot of examples. And quick new query. I won't go into all the details. We have short on time. I'll quickly go through it. Let's say like test query. And databases. Maybe let me select Telugu Wikipedia. And my question I have when you're doing an SQL query, it's always important to start with a question. Without question, you can't. Without question, you can't do SQL because you need to first know what you want to do in like any programming language. So let's think of a question. Like maybe the question is top top 20 users by their edit count. That's the question, very basic question. And maybe they registered in 2024. Maybe I want like who are the top editors who started editing this year, and they're like kind of like top 20, and see who they are. So let's first write all the keywords. Where, what to select from, where, order by, and then limit. That's the breakdown of the query. What, where, and the conditions. So I want to select just the username. See, maybe the user edit count. And the table is user table, where the condition I want to apply is like year of user registration equal to 2024. Order by, I want to order by user edit count. Maybe we can rank top editors, and then limit is 20. Give me top 20, because that's the question here. And you can just submit the query. Well, yeah, we have. So we have people who registered this year, and they have top editors. So how many made 2,000 edits? It's pretty cool. So this is live. This is actual Wikimedia project data. These are the editors who are making edits on the Wikipedia. So you can see this query example. So now, how did I know where like all these columns and everything? That is from the documentation. Earlier, I shared the database layout. So here you have the documentation, like so the user table, and like it has the user table where information about users, and you have the user ID, the real name. Of course, like don't worry, the password is not public. It is stored like as encrypted, privacy internally stored. If you query, it will give an error. So, but like other things like ID, edit count, registration time, those are public. So you go through this and like you understand what column is what. Okay, back to this presentation. So that's we have seen that's the first layer of operations, and then now, of course, like that's the basic, but then we can do a lot more. So the next one is grouping and aggregate, like with typical data analysis, like you have these operations like I want to count, I want the sum of like or average of the prices, or like the maximum salary, minimum salary. So the typical like basic mathematical function like operations like count, sum, average, min, max. So this is the sales table, example sales table with product, region, date of sale, and amount. And so I want to count all the sales in region north. So I just do select count star total all sales. From sales, the region is north, and the result is 2. And sum is like how much now in a company, how much amount did I generate? I want to see like how much revenue did I generate. So what I do is sum of the amount. So you can give an alias. So like I want this output column name to be like some other column name, total amount, total revenue, whatever. So you can name, like you can use this as keyword and rename the column, like rename the output of the aggregate. From sales, region equal to west, you have the amount like 1,050. Same with average of the amount, like what are the average sales and average sales. So this is average also, it's not just one region. So just do average. And then min sale, minimum, maximum, like what's the minimum sale or the highest sale. So whatever the column you want to apply on, just put the keyword before, apply brackets, and then like rename the column if you want, and run the table. Pretty simple. So now I want to apply. That's the basic, but most typically what you want is you want to know more in details. What if I want to apply? What if I want to know the like total sales by region? So then, what there is a key. The key is like you have to do what you call as group by. So group by is it will sum by each region and then give you the results. So you have to observe two things in group by. Is one is the region. Sorry, you have to select like in the output table. Like now, imagine I want to get the results by each region. So the output should be okay. The first column will be the region, and then what the total sum. So that is how you would structure the select statement. And then the group by will be the column which you want the grouping by. So I want the grouping by region. So if you put region here and then do sum, but then don't put the region in group by, what will happen is it will throw an error that you didn't specify the grouping function, because it should know what type of how to group the sum. Sorry, if I want to also group, like maybe I want region wise, product wise, total revenue, what I can do is add the product here, and then I would also add the product in the group by. So then the SQL engine will know that I have to group by both region and product and give you the results. So you have to see, you have to think like, imagine like if you're doing grouping, like imagine how you want the output to be, and then like you structure your query, not that. So region, not that's total sales. So I want having. So having is, it's like a where condition, but a where condition and having condition are, the difference is having is used when, so where is used, if the data is already in the table, you apply the filter. Having is used on data which you generate. So the sum of the amount, this value, this is you are generating. Amount is in the database, but not the total amount. So you are generating this information. And if you are applying a filter on the data you generated in the query, then you use having keyword. So, and then like, so yeah, total sales are greater than 1,000. Like, so you're basically saying, give me the regions which have sales more than 1,000 and like ignore the rest. Maybe these are the top performing regions. So I want to know that. So, and then, yeah, so from north, south, so north and west are the top regions. So east and west, they don't have lot sales. Okay, I will quickly pass through. I think we are little bit short on time. So, okay, now we have seen operations on a single table, but what if I want to do operations on a lot of tables? Because usually you want to get the orders from customers, like I want to get orders, customers, and then like maybe join with something else like product information to get a view. So everything has a different table. So you have to do join. So there are different types of joins. In school, if you remember, we had this, probably all of us had this thing where we had to join like the Venn diagrams, right? Like these are the Venn diagrams. So if you imagine two tables you want to join, like orders and customers, we'll go into how it is done. Like, so there are 4 keywords, the 4 types of join primarily. There are a couple of more which are like announced, but like at the basic, there are 4. If you just say join, which is also like an alias of inner join, the rows which are common in both the tables are kept. Full join is like all the rows are kept. Left is on the left table, the data is kept, and then like if the right table has a matching data, it will be added. If not, ignore. Right is the reverse. So right table will be kept, and then like there is additional information in the left to add that, and then ignore the rest. So that's the basic. It's pretty easy to visualize. So now I want to, so this is the order table and customer table, and then like customer ID. Now I want to join the customer name.
Krishna, I just want to add something. Sorry for interruption. Guys, there was some glitch from my side. I have given you contributor access so that you can put your comments and put your queries in chat box. Earlier, you were not access for this, but I've given you access. Please accept that permission and you can now put your queries in the chat box. Yeah, please continue, Krishna.
Thanks for the heads up. So, yeah, so, okay. The inner join is like, so what we are talking about left and right tables. So what is like the basic, like, the hallmark is like the query that comes first. What you specify in from is what you specify in from. The in from, like that is the left table, and then what you specify in the join is like the right table. So that's how what is left and right. The first table is the left, and then the second table is the right. So now you specify the table to join, and then you specify how do you want to join it. If you go to the previous slide, so we have the customer IDs here, and then the customer IDs here. So this is how you join. Like in the documentation, usually you will have the primary key, which will tell you how to join this table if you want to. So if you see in the user table, you'll have this user ID is the primary key. So in the documentation of any database, you will have this information like what is the primary key. So that is how you join the table. So customer ID is the key common index here, and then so you go and join that. So orders or customer ID equal to customers or customer ID. This here is saying that attach the rows where customer ID from orders table is equal to the customer ID from the customer table. And then we have the result. So the customer name, product, and the amount. So if you see in the previous one, there is no customer name. So in the previous one, there is no customer name. So since I added on customer ID, so that brought me this customer name column, which is newly added. So that's the inner join. And now left join is all the orders will be kept, and it will try to join customers. But if it doesn't find, it will still keep the orders, and then what it will do is it will produce a null value. So maybe, so this is like, okay, the account, maybe someone is buying without just registering, like creating an account. Sometimes we don't want to create an account. So this way you know how many are like registered users and like how many are like unregistered users. So that's the left. And then there is a right join, which is all the customers will be kept, and then we'll see orders. So you see this customer Eva, so she hasn't ordered anything. So it will just produce null for those fields. And then full join is both are kept, like all rows are kept, and then whatever is missing from each of the joins, like it will just give you null. So you'll have both like users which place orders without account, or like users who have account and have no orders. So that's basically joins. So we'll move to the last act before I hand over to Agamya. So CTEs and subqueries are a way to create multiple. Sometimes what you need to do is you'll need to create a view inside the table. Like you create a temporary table so that you can apply a further operation on it. Sometimes you can't do a full aggregation. So what you do is you aggregate at one level and then aggregate next level, next level. So then you need what we call as subqueries or like CTEs. Subquery, different, like there are different industry standards. So subquery is like you wherever you want to apply, you apply, like create a query inside that. So here you see the salary. I want employees who have salary higher than the average salary of employees. So I have like 100 people, and then what is the average if it's like 50,000? So I calculate the average in the subquery and then say, give me employees who are earning more than the average. So that will give me this result. So you can't do this in one query. So because you have to first calculate average, which is not in the table, and then you have to use that as a filter. So that's when you use subqueries. And so that's the result. So these people are who they have more than the average salary in their company. The CTE is same. The only difference between CTE and a subquery is like CTE, you define the query. Like in the previous example, you would define the average query here and then use it in the next like query, like using the width. Width is like a keyword where you can define a CTE. This is doing the same thing, but just the syntax is different. The only thing is like when you're writing complex queries, CTs are preferred because they are clear. Like you can easily refer them. And yes, this is like how you use CTs. You can have multiple CTs using a comma and like recent hires, old hires, highest paid employees. So you can have multiple CTs and use the two operations on them. Right. So yeah, so that's a quick recap. We have learned into introduction to SQL, basic data retrieving and filtering, grouping, joins, and CTs. And I will hand over it to Agamya for the next part of the slides. And if you have any questions, you can keep on asking, keep asking on the chat.
Thanks, Krishna. You can put your questions in the chat box. We are happy to answer those. I hope you are able to put questions. Yeah. So we have the first question.
I think in the interest of time, I will answer on chat itself. I think Agamya can continue with the next part.
Yeah, we have limited time. Yeah, please, Agamya, continue from this.
Okay, sir.
Agamya, do you want to share your screen? I will stop sharing.
Sure, I'll share this. So I think my screen is visible now.
Yes, yes.
So hello everyone. I am Agamya. I'm Agamya. I am a part of GLG Pragraj, and currently I am a full stack developer. And today I'll be your speaker for the rest of the session. So before proceeding, let's have a quick recap for everything we have learned today. So yeah. So you guys have got introduction to database, what's a database and what is a SQL. Then we have got a little bit knowledge about what are CRUD operations, create, read, update, and delete, and what are basic data retrieval techniques and filtering techniques, what are grouping and aggregate functions, different types of joins, inner join, full join, left join, right join, and then there are common table expressions and subtotal. So, the next topic is window functions analyzing data in context. So, what are window functions? So, window functions perform calculation across a set of table rows related to current rows, providing context and insight. So, you can think of a window function basically as performing calculations on individual rows within a group, but without modifying the structure of the table. Means we are keeping the original structure of the table intact. So there are various functions which we use in the Windows function. For example, there is a row number, then there is a rank, then there's a lead function, there is a lag function. So, so this is the sample table which we'll be using for the queries. And so the first one is row number. So row number is basically used to, like, you can say, providing row number to individual rows. So here is the query, like select sale ID. So this is the like normal select statement. We are like selecting the sale ID, region, amount, sale date. Then we are using the row number function. Now the row number function will order by sale date. So it will like order, rearrange the rows on the basis of the sale date as row number from sales table. So this will be the output. You can like see, uh, it has like ordered them on the basis of the sale date, and it has added a new row, which is the row number table. If you look at the original table, this was the original table, and it has now modified it and added a new row number column, basically. So uh, now if you are seeing the output like this, but the original table has not been modified. So the original table is still this only. But with the help of window functions, you can basically add another column to the table. So the next one is the rank function. So the rank function will add ranks. So let's say you have a table of students and their marks are written. So you want to like rank the students based on their marks. So you can use the rank function. But there is, you can say one thing, that if there are two students which have the same rank, so it will leave a gap. So here's the example. So in this example, we are like ordering by the amount and in the descending order. So the which you can say the amount which is highest will be given the first rank, and the one which is the lowest amount will given the lower rank. So here you can see the latest amount in the entire table is of 1500, so it's given rank one, and accordingly the rest of the ranks are given. So the next one is dense rank function. So dense rank function is very similar to rank function, but this function does not leave any gap in the sequence. So syntax is basically the same, only where instead of rank we are using dense rank here, and we are ordering by amount in the descending order. So yeah, you can see the same. It basically behaves same as the rank function, but it will leave no gap. And now the next one is lag and lead function. So let's say there's a special use case where you want to like, let's say this sale is of 1000 rupees. You want to know what's the sale before it. So you use the lag function, lag function. And let's say if you want to know what's the sale after this sale, you'll use the lead function. So this is like the syntax of it. So lag amount over order by sale date as previous sale, and lead function for getting the next sale. So here's the example. So let's say, for example, this one. On row number 4, the current sale is of 300. And if you want to like get the previous sale is of 1200. In the previous sale table, it's 1200. And for the 300 sale, what's the next sale? Next sale is of 550. So if you like look in the next sale table, it's 550. So for 300, previous sale is of 1200 and next sale is of 550. So the data is there, 1200 and 550. And now the entile function. So the entile function is basically, you can say, it divides the entire table into different, you can say, equal columns, I mean, equal groups. So let's say there is a table of orders and you want to like divide the orders into equal parts. And if you want that first five orders should be handled by employee one, then the next five orders should be handled by employee two, and so on. So you can use the entire function to divide the entire table into equal columns. So yeah, and the table is like divided into because there are four columns in the entire table. So it's divided. There are actually eight columns, and the it is divided into equal parts of four. because we mentioned four. So here it will divide the entire table into four equal columns. So yeah, it's giving like the first two sale ID is given bucket number one. The next two are given like bucket number two, and the next are like given bucket number three, and so on. So like it's divided into four parts now, the entire table. So the next topic is transaction. So what are transactions in SQL? So any like you can say any query you run or any data insert operation you're given or any update operation command you give into SQL, these all are treated as transactions in SQL. And then there are like asset properties. So any transaction like which you do in SQL follows the asset property. So what does asset stands for? Asset stands for atomicity, consistency, isolation, and durability. So atomicity basically means that all the operations should occur or none of the operations should occur. Means if there is some issue with the order, some issue with the execution, then the entire command will not be executed. If there is some issue in some part of the command, so it will like reverse the command. Then there is consistency. That consistency basically means that the data which is stored in the table should be consistent and it should be like according to the rules defined by the table. The schema, it should follow the schema, and if there is a not null property, then we should not be able to insert the data. So this is what consistency means. Then isolation goes for that if there are like different transactions, like different commands in SQL, they should be isolated from one another. Like they should not like interfere with one another. And then this durability means once the data is like stored in the database, it should be like stored permanently. Like it should not happen like I have given updated the table, but it's not it's showing to me like on the screen like yes it's updated, but on the table it's not updated. So it should not happen like this. Once like data is saved, like then it should be stored permanently. Then there's a feature of rollback. Let's say there is a like you have written a transaction which consists of multiple commands, and like if some error happens somewhere in the middle, so it should like reverse the entire transaction. Like the entire transaction should not happen. So this is like the sample table we should be using for the SQL queries. And so yeah. So for writing a transaction, so here's like you can see a basic syntax. So a transaction in SQL starts with a begin statement. Like begin, like it like denotes like this is like the start of a transaction, and like then there is the update. You can like then you can write the commands which you want. Like where we are updating the accounts table, and in that we are updating the balance by reducing the balance by 1,000 and where the account name is Alice. So we are like deducting 1,000 rupees from the Alice bank account. Then we are like updating the account. Then we are updating the balance of Bob by increasing it by 1,000. Then there is the commit statement. Commit statement is basically, you can say it's like we are telling like here the transaction which we are writing, it's now completed. So begin is like marks the beginning of a transaction and commit marks the end of the transaction. So yeah. So earlier to see the balance of Alice was of 5,000 and Bob was 3,000. So we are like deducting 1,000 from Alice's account and increasing the balance of Bob by 1,000. So this will be now 4,000. So this is like reduced by 1,000 and it is increased by 1,000. So now what's the rollback? So let's say while we are transferring balance into from Alice's account to Bob's account, there's some error occurs. So we want now in a transaction, let's say we are transferring money. We don't want that if we are like subtracting, like first we will subtract balance from Alice's account, then we will transfer to Bob's account. Now, let's say while transferring to Bob's account, some error has occurred. So now because some error has occurred, amount was not able to deposit into Bob's account. So we now need to like deposit that amount back into Alice's account. So we'll use the rollback statement. So here in this transaction, here it's like begin, then update account, set balance, reduce the balance by 1000, where the account name is Alice. Now let's say after this, some error occurs. We are not able to like find Bob's account. Let's say that his user ID is wrong or there is some issue with his account. Then the rollback statement will take place. So when the rollback statement will take place, the amount will like remain the same, 5,000 and 3,000, the original amount which was there. Uh, yeah. So showing, yeah, the rollback restores Alice's balance to 5,000, ensuring no partial transaction takes place. Yeah, it will like make sure the either the entire transaction will take place or none of them will take place. Now there's a concept of save point. So save point is basically you can think of it as like creating a checkpoint. So yeah, so you can like say here's like begin statement. Then there is we are updating Alice's balance by reducing it 1,000. Then we are initiating a save point here. Then we are like transferring, means adding 1,000 to Bob's account. Now again, let's say some error happened here. Now we will do roll back to save point one. Now we want that if you like save point is basically used if you like we want that the transaction, the entire transaction, if it fails partially. So we don't want to reverse the entire transaction. We want to like partially reverse the transaction. So in this case, if some error occurs on this line, so it won't like roll back the entire transaction. It will roll back it to save point one. So here. So all the statements written from here to here will be reversed, but statements written above this won't be reversed. So the balance 1,000 will still be deducted from Alice's account. Even if when we are not able to transfer to Bob's account, 1,000 will still be deducted from Alice's account. So we'll check. So yeah, earlier it was 5,000, now it's 4,000. But Bob's account is still 3,000. Means amount was not able to deposit on Bob's account. So hope you guys are not bored, not sleeping. Okay. Then moving on to the next one. Okay. So the next concept is indexes and query optimization. So what are indexes? So you must like all have like seen indexes in your books. So what's the use of index basically? So for example, if index is not there in the book, and if you want to search any particular topic in the book, so you need to like go through the entire book. You have to like search the entire book page by page for that particular topic. You need to read the entire book. But with the help of indexes, like you like check on which topic is present on which page. Let's say if your topic is present in page number 53, you can like immediately go to page number 53 and like you don't have to read the entire book for it. So what's the advantage of indexes? So indexes basically you saves your time. Like if there's a huge table, like if you want to search a particular data in the table, if there are no indexes, the SQL database will scan the entire table for searching a query. But if we have indexes, it will know exactly where the data is present, and the query will take lot less time as compared to when there are no indexes. And there is query optimization. So the query optimization is only helpful when you have a huge data. Let's say if you are having a sample data table which is consisting of only 10 or 20 rows. So optimizing on that point of time will not make much of a difference because there are only 10 to 20 rows in the table. But let's say if you are working in a production, if you have a huge database consisting of millions and billions of rows. So at that point of time, query optimization is very necessary. So in small databases, query optimization like won't make much of a difference. But in like a huge table, it will make a lot of difference. And indexes basically they are implemented using B trees. So you must have like studied in a college what are B trees. So here is a like, quick example of how a B tree looks like. Uh, so this is the sample table which we'll be using, the employees table. And yeah, so this is how like we create an index. So create index in IDX department. Like this is we are giving name to the index. So IDX department on employees department. So we are like creating an index on the department column of the employees table. So yeah, that's how we'll create the index. So now if you'll run any queries related to department column, it will be much faster. And now composite indexes. Let's say if we want to like create indexes which consist of multiple columns. Now, like here, we have only created index on a single column, department column. But now, if we want, let's say, create an index which consists of department and salary also, because we have many queries which require both department and salary column. We will create a composite index consisting of department and salary column. So that is how we create an composite index. Create index, then name of the index on employee table and department and salary column. So this will like create a composite index on both department and salary column combined. So yeah, this is how you will write an optimized query. Select star from employees where department I is equals to IT and salary is greater than 80,000. So this like because we have already created an index, so the database will avoid scanning the entire table because it now already has the index for it. So yeah, indexing on primary keys. So yeah, creating an index on primary keys like it's like very important because uh, it's very often like you will search by employee. You can say, for example, in this table, it's very often that you will like try to find the employee by employee ID. There could be like first name. There can be many people with the same name, Alice. There can be many names with Bob, but employee ID is unique. So it's very important to like create a primary, creating an index on a primary key of your table. Yeah, let's see. Then query optimization techniques. Yeah, so query optimization uh, techniques goes for like mm, yeah. So avoiding select star. So let's say in this table, uh, employees table, you want to like get first, like get the entire data, employee ID, first name, last name, department, salary, hire date. So many of time we'll do like select star from employee table, but it's not like recommended to like use select star because it can slow down the database in many ways. So it's like preferred to like specifying the columns which you want, like select first name, last name, salary, hire date, employee ID, and mentioning that. And yeah, like avoid select star, then index. Like if you're aware that you will be searching on but these particular columns quite often, so like you can create indexes on those particular columns. So like all these ways you can like optimize your query in database. Uh, yeah. So the next topic is text search using like and regex expression. So like basically you can think of it uh, like will be for example, yeah. So like here in this table we are searching for product name which have pro in them. Means for example, yeah, this is the sample table which we'll be using. So like this is the iPhone Pro Max, then there's Pro, iPad Pro. So yeah, so all the products which have the name Pro in them, it can be present in the beginning of the string. It can be present in the middle also. It can be present in the end also. So yeah, so the like statement is basically searches the entire string for present presence of the entire string. Yeah. So close table. So yeah. So this like searches the it returns the product name with all the pro with the pro keyword in it. So I hope you guys are like not getting the meaning of this meme. So there's like it's very confusing. Like which should you buy? Like iPhone 14 Pro Max should you buy or iPad Pro? Because iPad
They
Pro is
they all need iPhone 16.
okay. Oh, iPhone 14 is like too old now. iPhone 16 is the newest one. So this table is very old. Need to update this table. Yeah. Now let's say we want to find like the exact pattern using the like statement. So where select star from products where product name like Mac star. So the Mac percent, if you're using like Mac and then percentage at the last, so it will search in such a way that the Mac keyword should be present in the starting of the string. Like previously, if you check, yeah, pro, and then we have used the percent symbol before pro and after pro. So this denotes that we are like want to search the word pro anywhere in the string. Like it could be present in the beginning, in the middle, or in the end. But by mentioning Mac and percentage at the last, we are like telling the database to like search the keyword Mac, but the Mac should be present in the starting of the string. So yeah, it will like return the product name with the starting Mac. Right. And because the MacBook Air starts with the word Mac. Then single character search using like. Yeah. Uh, we want to like uh, search the words which have the word S. S means the word starting with the letter S in their name. So Samsung Galaxy S23. So yeah, because Samsung starts with the letter S, so it will search single character to advanced search text search using regex expression. So now, if you want like get all the queries which have the word pro or max in them, like means basically we want the product names which have both pro and max in them. So you'll use the pro, then we'll use the or symbol, then the max. So it will like return all the products which have the word either pro in them or max word in them. Yeah. Product pro is present in this and max is also present and pro is also present in the arrow. Yeah. So now if you want to like do a case insensitive search using regex expression. So yeah, so this is like the syntax for like doing a case insensitive uh, search. So like uh, so round bracket, then question mark, then I, and round bracket close, then here, and then the dollar. So like this is the syntax for case insensitive. So it will like search for the word air. Now words can like somewhere air could be written with capital A, somewhere it could be like written in different ways, but it will like find the word which contains air in it. This is what like. And now if you want to like get the name of all the products which do not have the word pro in them. So we'll use the not like keyword. So it will return name of all the products which do not have the keyword pro in them. So yeah, MacBook Air does not have the word pro in them. And rest of the products they do not have the keyword pro in them. Now searching with the character set. Then the character specify the start of the string and also naturally the search. Yeah. So it will like you can say it will try to match the words S or G. Like for example, if you saw here with the Pro and Max. So if we want for the single character like S or G, so it will like search all the strings which have S and G in it. Yeah. starting with S and G because they like respectively start with S or G. So this is yeah. Now, like you can, the next topic is like SQL dialect. So SQL dialects are basically you can say variations of SQL, or like in simple words, like if you must have heard about MySQL, PostgreSQL, then there's Microsoft SQL Server and SQLite. So these all are database servers only. Like they follow the basic SQL structure means like they follow the same syntax of SQL, but like they have a slight modification in them. Like for example, uh, creating joins in MySQL is different from creating joins in Microsoft SQL Server or in Postgres, or like creating indexes is like slightly different in SQLite. So like these all have basic commands which are like similar. So like you can say these all are derived from a SQL, the SQL language, which is like the parent language, and they like all are derived from that same parent, which with slight modification in each of them. So also there's like Apache, Spark, and so all these are like basically they just follow the SQL language with slight modification. Then there comes the order of execution SQL query. So yes, so here is a sample query. Let's say you are written select column A, column B from table T1, join with table T2, and like on T1 column A, T2 column A with constraint. We have written some condition here. Then group by column and having constraint expression order by. So this is like you have written the query, but it's not necessarily in the same order it will get executed. Like SQL has a specific order in which you will means the database will execute the query. So yeah. So this is like given like graphical representation of how a SQL query is executed on the database level. So here, like you usually select distinct, like this is like the first statement. Then you like from table one, join table two, where group by. So like this is the like step one, step two, step means statement one, statement two, statement three, statement four. Like in this order, usually people write. But on the database level, first like the this from and join statements are executed. Then the next are where statements are executed. Then after that, group by statements are executed, which will like group that table according to the column which you have given. Then having statement will display means apply any constraint available. Then step four after the step five select. Select will like select the tables like whichever column name which you have given. It will select those table. Then after step five is step six order by. Then it will order them whichever order you have given ascending or descending order. Then in the last it will apply the limit. So you are like given limit two, so it will only display two results. So basically, the conclusion is that the order in which you have written a SQL query, it's not necessarily it is executed in the same order. So for example, the select statement you have written in the first phase, so like the first statement was the select statement, but it was executed on the fifth step. And for example, here, the group by statement which you have written on the fourth statement, which was executed on the third step. So this is like very important to understand the coding order may not be equal to the execution order. And understanding the execution order is very important because when you are working in a production data, there is a huge database. So understanding these queries, if you like understand how the execution order works, so it helps to like create queries which are much more optimized. Like it will take very less time to execute. So yeah, so like this is like another diagram showing the same. So yeah, yeah, that's it.